Hello students, welcome. Previously, Form 2, Topic 2, Lesson 10, we were dealing with chemical properties of alkaline earth metal. We have done the first three. So today, Lesson 11, we are going to proceed to the fourth chemical properties of alkaline earth metal. That is reaction of alkaline earth metal with chlorine. So we start with the magnesium, and next we are going to go to calcium metal as members of alkaline earth metal. So we are going to see the observation that's made when magnesium reacts with chlorine. So we are told when a burning piece of magnesium ribbon is lowered into a gas jar containing chlorine, the observation that we are going to see is the magnesium continues to burn with brilliant white flame to form a white border. Reason is this is because magnesium reacts with the chlorine to form magnesium chloride. Remember, when a metal reacts with chlorine, we are going to get metal chloride. So here we have magnesium solid reacting with chlorine gas, giving us magnesium chloride, and this chemical equation is self-balanced. So number B, we are going to see calcium reacting with chlorine. So the observation we are saying, calcium continues to burn in chlorine with bright red flame to form a white solid, to form a white border. The reason is that this is because calcium reacts with chlorine to form calcium chloride. So the reaction is calcium solid reacting with chlorine gas, giving us calcium chloride, which is solid. Thereafter, we are told note calcium may not readily react with the chlorine. We are saying calcium may not react steadily with the chlorine. The reason is that this is because a coating of calcium oxide is formed first when the metal is heated. However, under suitable conditions, calcium may react with chlorine to form calcium chloride. The fifth chemical properties of alkaline earth metal is reaction of alkaline earth metal with dilute acids. Number one, we are going to start with magnesium metal. When a piece of magnesium metal is added to both dilute hydrochloric acid and dilute sulfuric acid, there is a formation of effervescence. That's the observation. Formation of effervescence or bubbles. The reason is this is due to the production of hydrogen gas. Remember, when a metal is added to dilute acids, we are going to get salt and hydrogen gas. So because of the production of the hydrogen gas, there is a formation of bubbles or effervescence. So those reaction is magnesium solid reacting with dilute hydrochloric acid solution to give us magnesium chloride solution and also hydrogen gas. So when magnesium reacts with dilute sulfuric acid, we are going to get magnesium sulfate and also hydrogen gas. So because of the hydrogen gas, that's why we are seeing the observation as the formation of effervescence. But B, we are having calcium metal. When a piece of calcium metal is added to dilute hydrochloric acid, there is a formation of effervescence, and this due to the production of hydrogen gas. That reaction is written here, calcium solid reacting with dilute hydrochloric acid, giving us calcium chloride and also hydrogen gas. So we said note, when a piece of magnesium metal is added to dilute sulfuric acid, the reaction quickly stops, or the reaction comes to an end after some time. The reason is this is due to the formation of calcium sulfate, which forms a coating on the surface of calcium metal, preventing further reaction. So the reaction to support that is when calcium solid reacts with dilute sulfuric acid, we are going to get calcium sulfate, and which is a precipitate and also hydrogen gas. So this precipitate coats the metal. That means the calcium metal, thereby preventing any reaction from occurring. Remember, we said all sulfates are soluble except barium sulfate, lead 2 sulfate, and also calcium sulfate. So number 6, we are going to go to reactivity of alkaline earth metal. We are saying the reactivity of alkaline earth metal increases down the group, and the reason is this is due to the increase in the easy losing electrons as the size of the atoms increases down the group. Remember, when we are dealing with the graduation in the size of atom and ion, and that side of atomic radius and ionic radius, we said the atomic radius of alkaline earth metal increases down the group. The reason is due to the increase in the number of occupied energy levels. So as the number of occupied energy levels increases, that means the is losing electrons also increases down the group, thereby increasing the reactivity of alkaline earth metal. So for that, we said calcium is therefore more reactive than magnesium. So next we want to go to similarities of ion and formula of some compounds of alkaline earth metal. We have the ion of magnesium and also calcium. We have hydroxide ion, we have oxide ion and also chloride ions. These are the ions. Here we have magnesium and also calcium. So what is the formula of the compound formed when magnesium reacts with hydroxide ions? We are going to get magnesium hydroxide, which is written Mg in bracket OH close bracket 2. The reason why we are putting the 2 down there is that magnesium has a valence of 2 and hydroxide radicals has a valence of 2. So exchange of valency will take place. So calcium reacting with hydroxide, we are going to get calcium hydroxide, which is written Ca in bracket OH close bracket 2. Okay, if you know how to write magnesium hydroxide, it is very easy for you to know also how to write calcium hydroxide, because you only change magnesium to calcium. The rest or the formula will be similar. We are dealing with similarity. And the reason why they are similar is because they have the same valency or valence electron. So here, magnesium reacting with oxygen. Remember, magnesium has a valence of 2 and oxide has a valence of 2 or oxygen. So they are going to go together, those two. We are going to simplify them. We are going to get Mg as the formula for magnesium oxide, calcium oxide to be the same. We have chloride ions here. Remember, chloride has a valence of 1, magnesium has a valence of 2. So they are going to exchange the 2. So chloride will take 2. So that's how we are going to write magnesium chloride. The same as calcium chloride. Calcium has a valence of 2, chlorine has a valence of 1. So what will happen is that calcium has a valence of 2, chlorine has a valence of 1. So they are going to exchange, or we are going to cross. We are going to interchange the valency. So these two will come this side, that one will go that side. So the formula will be Ca1, we don't write 1 in chemistry, then Cl, then we are going to write 2. That's how we are going to write calcium chloride. So next we are going to go to the uses of some alkaline earth metal and their compounds. The first one we are having beryllium there. Beryllium is used to make windows for X-ray tubes. Number 2, we have magnesium, which is a member of alkaline earth metal. Magnesium is used in the manufacture of magnesium hydroxide, which is used as anti-acid medicine. This is because magnesium hydroxide is non-toxic base. Number 2, or the second use of magnesium is that we are told a low density alloy of magnesium and aluminum is used in aeroplane construction. Then the last one, we said magnesium oxide is used in lining of furnaces. That one we are going to see when we are dealing with chemistry of metals in Form 4. So next we are going to go to calcium. Calcium nitrate is used as nitrogenous fertilizer. Number 2, or the second use of calcium, we are having calcium oxide or quicklime is added to acid soils to raise pH for agricultural purpose, the pH of the soil. So the third use of calcium is calcium carbonate is used in the extraction of iron. Then next we are having calcium carbonate is mixed with oil to make booty. Then next we are told cement is made by heating a mixture of calcium carbonate, which is limestone, clay and also sand. And lastly, the last use of calcium, we are told hydrated calcium sulfate or plaster of Paris, that's its common name, is used in hospitals to set fractured bones. So lastly, we're having barium. Barium sulfate is used in diagnosis of ulcers. Then the last use of barium nitrate that we have here is barium nitrate is used to produce the green flame in fireworks. So that ends to the that side of alkaline earth metal. In our next class, we are going to see halogens.